Welcome to my channel. This is the quiz 2 we wrote, and then I'm presenting the solutions. So for the question 1, it says we should find the oblique asymptote of the function, and the function is given to us as h of t to equal to t 2t squared minus t minus 7 all over t plus 2. But before we can solve for an oblique asymptote, we should know what an oblique asymptote is. Now, when we say an oblique asymptote, we are saying that for a rational function to have an oblique asymptote, the degree of the numerator should be greater than the degree of the denominator. So denominator by 1, by exactly 1. So what we want to say is that to be able to find the oblique asymptote, the degree of the numerator should be greater than the degree of the denominator by 1. If that be the case, so in our case here we have 2, the degree here to be 2, and the degree here to be 1. And so if you compare, you can see that the degree of the numerator is bigger than the degree of the denominator by 1. So we can find the oblique asymptote. If that be the case, we divide the numerator by the denominator. And so in that case, we will have something like this. We have 2t squared minus t minus 7. Then we have t plus 2 out. Now we divide. T divides 2t squared. We will have 2t. Then 2t times t will give us 2t squared. Then remember 2t times 2 will give us positive 4t. Then we subtract as we do for long division. So when we subtract, we are going to have 2t squared minus 2t squared. That will give us 0. Then negative t minus positive 4t. That will give us negative 5t. Then nothing happens to the 7, so we drop it, negative 7. Now the next thing is that we can still divide. T divides 5t, we'll get negative 5. So 5 times negative 5t times negative 5 times t will give us negative 5t. And then negative 5 times 2 will give us negative 10. We do our subtraction, and when we do the subtraction, we'll have negative 5 minus minus 5. That will give us 0. Then negative 7 minus minus 10. That will give us 3. So positive 3. So this is what we have. Now, this t cannot divide 3. So this becomes the remainder. And hence our oblique asymptote h will be equal to 2t minus 5. And so the correct answer is B. Now we go to question 2. Question 2 says, which of the following does not have a horizontal asymptote? Now, for a particular rational function to have a horizontal asymptote, one of these conditions will be true. The first condition is that 1, if the degree of the numerator is greater than the degree of the denominator, then we are saying that there is no horizontal asymptote. And then the second one is that if the degree of the numerator is less than the degree of the denominator, then we are saying that the horizontal asymptote is y is equal to 0. And then the third point is that if the degree of the numerator is equal to the degree of the denominator, then what do? We just have to take we say our horizontal asymptote y is equal to the leading coefficient of the numerator over the leading coefficient of the denominator. So that is what we are saying. So any of these conditions that are met, we know what to do. Now, so they are asking which of these does not have a horizontal asymptote. So we just have to compare these conditions and then check out for the first one. So here, the degree here of x here is 0, and the degree of x here will be 2, right? When we do the expansion, we'll get 2 here. So that is 0 and 2, where we can see that 0 is less than 2. So the horizontal asymptote here will be what? Y is equal to 0. So there's a horizontal asymptote. Here 2, we come to B. Here the degree is 1. Here the degree is 1. So they are equal. So we can find the Y by using the leading coefficient. Then we come to C, it's also 1 and 1. They are the same. So we can also use the third point where we can find the leading the ratio between the leading coefficient. Then the D, when we check that one, we can see that 3 is greater than 2, and that is what happens, that the degree of the numerator is greater than the degree of the denominator, and so hence our answer is D. So that is the question 2. All right, question 3 says find how many vertical asymptotes does the graph have. So to find a vertical asymptote, the first thing you have to think about is that you should check, can the function be reduced to its simplest form? If it is a yes, do so before you find the vertical asymptote. And so if we check this particular rational function, we can't divide further, right? And so what we will do is that we will just equate the denominator to 0. So we have 2x minus 1 and then 5x plus 3 to be equal to 0. Now when we solve each one of them, we have x to be equal to half and then x to be equal to negative 3 on 5. But the question says how many vertical asymptotes. So it is not the answer we get, but how many of are they. So we count 1 and 2, and then we choose the correct answer, which is C. So reading the instruction and understanding the question is also part of the examination. So you should be able to tell us that, okay, the question is saying that we should find how many. So if you're able to find the number of asymptotes, then you count them and then we have how many? 2. Now question 4, it says that which of the following has oblique asymptote? As already I've explained in the first one, the oblique asymptote should have so for a function to have an oblique asymptote, the degree of the numerator should be greater than the degree of the denominator by exactly 1. So let's check. When we check this one, it is 1 1, so there's no oblique asymptote. We check here is 1 2. The numerator is less than the denominator, so there is no oblique asymptote here. We check this one, you can see that here is 2 and here is 1. Now the numerator, the degree is 2, the denominator, the degree is 1. So if you compare, you can see that the top is bigger than the down by 1, and so that will have an oblique asymptote. So that is all about question 4. Then we go to question 5. Question 5 says that we should find or evaluate the function. So if you want to evaluate, you are finding the value of x. So what do we do? What we do is that we 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 solve what we have. That is 3x equal to 5x minus 2. How do we solve for x? We can drop the x. How? We use the log function. So log 3x to be equal to log 5x minus 2. Then what we do is that based on the, sorry, there's a mistake here. So it's raised to the power x, not x. So if I solve this, I'll have x dropping. I'll have x log 3 to be equal to x minus 2 dropping. Then we have log 5. Now we can expand what we have on the right hand side, and we have x log 3 to be equal to, now x times log 5, we have x log 5 minus 2 log 5. Now we group like terms, we put all the x's at one side and then all the other ones that are not there at the other side. So when I'm doing that, I have x log 3 minus x log 5, and then that should give me negative 2 log 5. Now I can factorize x out. If I factorize x out, I'll have log 3 minus log 5. That'll give me negative 2 log 5. I divide through by log 3 minus 5, so I have log 3 minus log 5 over log 3 minus log 5, and that will give me, this will cancel that, and I'll have x to be equal to negative 2 log 5 over log 3 minus log 5. Now we take the negative down, multiply through the denominator, and then we'll have x to be equal to 2 log 5 over log 5 minus log 3. Now when we get to this point, you can also choose to send the negative 5 here and then bring the log 3 here. Then here you don't have to mind what we did here, where we just use the negative to multiply through. But if you want to go by what I did, then when you get here, for you to get the correct answer here, when you compare all of them, there's no negative 2 there. So you have to see where the manipulation counts and then you select. And so the answer is B. Now question 6. Question 6 is we should decompose this fraction and then into its partials. So what we'll do is that we should understand what is here. So we are given 7x squared plus 1 all over x plus 3 and then x minus 1 all squared. Now there is a linear factor and there is a repeated factor, and so we go into the archives when we have a linear factor. So for instance, if we have let's say x over x minus 1 x plus 1, what we are saying is that if you want to decompose, we use a over x minus 1 plus b over x plus 1. The same thing. Now that is when we have a linear factor. When we say linear factor, the degree here is 1 and then here is also what? 1. So that's why we are saying that. Now when it is a repeated factor, for instance, if you have x over, let's say, x plus 1 squared, then this is how you go about it. When you are decomposing, you have a over x plus 1 plus b over x plus 1 squared. You get it? And then when we have x over, let's say, ax squared plus bx plus c all over, and then x plus 1, we have this one, we call it a quadratic factor. And so if you are expanding it, you have ax plus b all over the quadratic factor, which is ax squared plus bx plus c, then plus c over, let's say, x plus 1. So that is how we can do that. So these are the principles we can apply when we are decomposing. And so when we want to decompose this one, you can see that we have a linear factor here and you have a repeated factor. So we'll combine the two ideologies to find that. And so our a will be over x plus 3, and then plus our b over x minus 1 plus our c over x minus 1 squared. Now we simplify this one and equate it to the numerator. So if I'm going to simplify, I'll have to find an LCM, and the LCM will be x plus 3 multiplying x minus 1 squared. So if I multiply 2 by that, I will have a. Now when I multiply this one by that, this will cancel this one, leaving us with only x minus 1 all squared. So we have x minus 1 squared, then plus my b. When I multiply to x minus 1 will cancel one of this x minus 1, leaving me with x plus 3 and then x minus 1, then plus c. Now when I do the c2, this one will cancel that, leaving us only with x plus 3. Okay, so the next step is that, and that should give you the numerator, which is 7x squared plus 1. Now we have to find the values of a, b, and c, and then we put them back into the function that we have. Then that will be it. So what we do next is that we find a factor that can give us some zeros. So we can say let x be equal to 1. And so if x is equal to 1, if I put 1 here, what happens? This one goes to 0. If I put 1 here, this one goes to 0, leaving us with this one. So we have c bracket 1 plus 3, and that will be equal to, if I put 1 here, I have 7 into bracket 1 plus 1. So if I do that, I have 4c to be equal to 8. I divide through by 4, here by 4, and I'll get c to be equal to 2. So I have my c now. I have my c now. I have my c. Then I'll do the same thing for my b, or any of them that I can find. So I can also say that let x be equal to -3, and if x is equal to -3, what do I have? This one will go to 0, because if I add -3 to that, that will be 0, and then times this will give me 0, times the b will give me 0. This one too will have 0. Then we'll have a bracket -3 minus 1, and if I put -3, if I square that, I'll have 9. And so I have 7 bracket -3 squared plus 1. And this one should give me, and please don't forget there's a square here, a squared. So we'll have -4 squared. That will give us 16a to be equal to, now when I square this one, I'll have 9. 9 times 7 will be 63 plus 1, that will be 64. So we have that, and I'll divide through by 16, here by 16, and I have a to be equal to 4. Then we go to the last part where we have to find our b. Now to find our b, we know a, we know b, so we can just equate, we can just put them in. So our a is 4, so we have 4 bracket x minus 1 squared plus my b, which still I don't know, x plus 3 x minus 1, and then plus my c, which is 2, and I have x plus 3. So that should give me 7x squared plus 1. And so in that case, what I'll do right now is that I will let x to be equal to 0. So if x is equal to 0, what happens? If I put 0 here, I have -1 squared. So I have 4 bracket -1 squared plus my b. So if I put 0 here, 0 here, I'll still have b bracket 3 multiplying -1, and then plus, if I put 0 here, then I have 2 times 3, that'll give me 6. And then if I put 0 here, the whole of this one goes away, leaving us with only 1. So that will be equal to 1. Now let's simplify whatever we have here. If I square -1, I have 1. So 4. Then if I multiply this through by, so I have 3 times -1. That will give me -3 times b. That will give me -3b plus 6 is equal to 1. Now when I add the two of them, I'm going to have 10. So -3b, if I take the 10 across, I have 1 minus 10. That will give me -3b to be equal to -9. If I divide through by that, I have -3, -3, and then b will be equal to 3. So b is equal to 3. Now we have a to be equal to 4, b is equal to 3, and then c is equal to 2. So let's go and substitute it back into the function, and that will give us the value. And so if you check the answers, which one corresponds? We'll have a 4 over x plus 3 then 3 plus 3 over x minus 1, and then 2 over x minus 1 squared. And so the correct answer is B. So it has been decomposed nicely. All right. Now let's move on to question 7. Question 7 says evaluate log m and then to the base m raised to the power 2n. Now, from the rules of logarithm, we know that if we have an exponent, we can drop it by what? By that rule. So we have log to the base m raised to the power 2n. We can drop that and we'll have that one to be the same as 2n log m to the base m. Now, from the rules of logarithm, if you have a log to the base of the same number, that will give us 1. So we'll have 2n into bracket 1, and that will give us 2n. And so the question 7 is D. Now let's go to question 8. Question 8 says x minus find the values of x. So we have 5 raised to the power 2 minus x to equal to 1 over 125. Now 1 over 125, we can rewrite or express this one in terms of powers. And so when we break this one down, we are going to have 5 times 5 times 5, and that is the same as 5 raised to the power 3. So we have 5 raised to the power 2 minus x to be equal to 1 over 5 raised to the power 3. We can rewrite this sentence, and then we have 5 raised to the power 2 minus x to be equal to 5 raised to the power negative 3. Now they have the same base, so we can equate the numerator, the powers. So we have 2 minus x to be equal to negative 3. Then I'll find the values of x. And then how do I find the values of x? I'll group like terms. Then I have x to be equal to, so I take x here, and I'll bring the negative 3 here. So I have x to be equal to 2 plus 3, and that will be equal to what? 5. And so the correct answer is 5. Okay. Now let's go. Question 9. They say using the transformation from y is equal to the absolute of x to y is equal to 2 absolute of x minus 4 plus 1, find the intercept of the new function. So we are going to find the intercept. Now for intercept, if you are finding y intercept, that means that x is what? X is 0. So finding y intercept, x is what? X is 0. X is equal to 0. So in that case, x is equal to 0. We substitute it into the function where we have y to be equal to 2 absolute of x minus 4 plus 1. So x is 0. So I'll substitute that. I have y to be equal to 2. And then we have 0 minus 4. That will be plus 1. Then 0 minus 4 is negative 4. So we have 2 negative 4 plus 1. But the absolute of every number is positive. So that's what we are going to have this one to be 2, and then absolute of negative 4 is 4. So 4 plus 1, and that will be 9. So the y-intercept is 0, 9. Now let's find the x-intercept. So the x-intercept, that means that y is what? Y is 0. So this particular function becomes 0 to be equal to 2 absolute of x minus 4 plus 1. Now I can take the 1 across, and I have 2 absolute of x minus 4 to be equal to negative 1. I divide through by 2, here by 2. I have absolute of x minus 4 to be equal to negative half. Now, from the rules of absolute functions, we know that x minus 4 absolute, there is no way it is going to give us a negative answer. And so definitely we are going to say that here we can't find a value for x, and this particular equation is not true. So we can't say that. So hence there is no x as there's no x-intercept. There's no x, no, hence no x-intercept. And so which of them fits? So there's no x-intercept, and then y-intercept is 0, 9. And so this is our answer. That's question 9A. Question 10, we are given a function, a sequence, and then they told us that the sequence is a geometric sequence where we have 6, 2, 2 over 3, 2 over 9. Now we are being asked to find the common ratio. To find the common ratio, we take the sequence succeeding the other one and then divide it. So when we are going to do that, we have here the first the number that comes after the 6 is 2. So we have 2 dividing 6, and that will give us, when we simplify, we have 1 over 3. Someone might also choose to take the third one and then the second one, but it should be consecutive, and then you divide, then you get 1 over 3. So here the common ratio is 1 over 3. Now, to find the value of the sequence, when we say value, mostly if we are doing geometric sequence and we say find the value, then we are talking about the sum of the sequence to infinity. And then for the sum to infinity, we are saying that if we are summing and then our r, that is the common ratio, is less than 1, the sum to infinity is giving us a over 1 minus r, where a is the first term and then r is the ratio. R is the ratio. So the first term and then the ratio. So we know our first term from the question is 6, and then our ratio is 1 over 3. So we have 1 minus 1 over 3. And when we simplify, we're going to have 6 over 2 over 3. Now with your calculator, you can evaluate this, or you can go by manually, where you have 6 multiplying 3 on 2, and that will give us 18 over 2, and that's equal to 9. So our correct answer is what? 9. Then we go to question we go to question 12. Okay, so question 12, it says that write an expression of of the of the sequence, the partial sum. So we are going to write the partial sum, the sum of the partial sum, the expression for the partial sum. Now we know that our r is less than 1. So when we want to find the sum, or the partial sum, we say that for the geometric sequence, it is Sn is equal to a bracket open 1 minus Rn all over 1 minus r. So in that case, we are saying that our a is 6, right? So we have 6 out bracket 1 minus our r, which is 1 over 3, all to the power n, all over 1 minus 1 over 3. Now to simplify, we will have this one to be equal to 6 bracket open 1 minus 1 over 3, right, raised to the power n, all over 2 over 3. Now we take the reciprocal, we're going to have 6 1 minus 1 over 3 raised to the power n times 3 over 2, and that will give us 18 over 2 times 1 minus 1 over 3 n, and then that will be equal to 9 out 1 minus 1 over 3 all to the power n. And so that is all for question 12. Now, so the correct answer is is A. So if you compare, you have A. Now we go to question 13. Now question 13, we're given 4 diagrams and then we're asked to match. So this one is like we are matching the correct diagram to the correct function that we have here. Now for any radical, the general form of a radical, so if we are using g of x, the general form is a root of x minus h plus k. That is the general form of any radical. And so if we are given the general form of a radical, now h and k are the vertices. They are the vertices, or we can say that we call them the starting point. The starting point. And so for this question, we were expecting you to find the starting point, and then with that, the help of the starting point, and then the value of a, we can determine whether we are going to choose a or b or c or d. So here we come. The first one, we are saying that which sketch represents g of x to be equal to root of x plus 2 minus 2. So let's see what is the starting point. When we compare this function to what we have here, we are going to have negative h to be equal to 2. So it is now negative h is equal to 2, right? That is what we have here. When I want h alone, I have h to be equal to negative 2. And so the starting point will be negative 2, and then what? Our k. What is our k here? Negative 2. So negative 2, negative 2. Now we come to the graph and we check negative 2, negative 2. Where can we find that? We can see that we have negative 2, negative 2 here. Here's 1. So can we have another one somewhere? No. So automatically the first answer, or question 13, is what? Is P. And so we just come and then circle our P. So that is all for that one. Then we go to question 14, sorry. Question 14, we have this. Now what we have here is root of x plus 2. So we compare this one to what we have here. And when we compare, we are saying that h will be what? Will be negative 2. And then what is our k? There is no k here. So it is 0. So our vertex is negative 2, 0. Right. Now we come to the graph. Now for the graph, we have negative 2, 0 here. And then we have another one, negative 2, 0 here. But now here comes the big problem, or it's not even a problem. Now the value of a determines which one we should choose now, because now we have two graphs we want to choose from. Now if a is positive, the curve or the graph curves downwards. If a is positive, the curve runs downwards, or it curves downwards. And if a is negative, the curve moves upwards. So we will have upwards and then downwards. So looking at this one, our a, that is the value in front here, is positive 1. And so positive 1, the curve will move what? Downwards. And so which of them is moving downwards? Then we just know that it is what? It is scale, because it is moving downwards like that. And so we are saying that the question 14 is B. Then question 15 is just direct opposite of question 14. So if you know that A curves that downwards, then B will be curving what? When it's negative, it will curve upwards. And so in that case, we choose our answer, which is what? C. So that follows. So that was for the objectives. There were 15 objectives, and those are the answers that has been given. Tell me your which one that you find it still difficult in the comment section, and let's see if we can engage. Accurate, and then it is on point, it is defined. Now if there's anything that will make this thing undefined, then we are saying that when the denominator, this one, is equal to 0. So to be able to find the domain, we have to equate the denominator to 0 and make sure that we take all those numbers that when we put in here, we'll get a 0 from it. Then now the remaining numbers become the domain of the function. So what we are doing is that we are just going to equate x squared minus x minus 2 to 0. And in that case, we'll have x squared minus x minus 2 is equal to 0. Now, when you can use your calculator to evaluate this, then, or you can use the quadratic formula to evaluate this, or use the factorization. So if I'm going to use factorization, I'll have x squared minus minus, if I which number will I multiply? The factors of 2, that will still give me -2, and then when I add, I'll get -1. And I know we will take -2x plus 1 and then minus 2, so that will be plus x minus 2 equal to 0. Now if I factor, I have x out, x minus 2, and then plus x out, plus 1 out, x minus 2, and so the factors will be x minus 2 and then x plus 1. Now if I equate them to 0, that means that x equal to 2 and then x equal to -1 will give me a 0 here. So if I put x is equal to 2 here, the whole function will become undefined. So I'll write my domain as the set of x is such that x belongs to all real numbers except x equal to 2, uh, uh, x equal to 2 and then negative what? 1. So this is how we can write it. Or someone might choose to write it in the form of uh, in the form of in the bracket notation. So we can write that one as, so let me write it here. We can write that one as negative infinity to -1, because all the numbers from negative infinity, when we put them there, all the numbers there, and then -1 up to -1, but -1 is not included, union -1 and then 2, union 2 to infinity. So we can write it as that. So this is what you can write. Or you can also write it as x is such that x belongs to all real numbers. X is not equal to 2, -1. All right. Now I have a Microsoft form where you will be answering this question. But when you get to this point and you want to type, there's not there, you can't see an e there like this. So if you want to type your domain as you see here, when you want to type that one, what you have to do is that when you get there, you hit the backward slash. So backward slash. So when you want to type, you just click on the curly bracket. You type x is such that x, they belong. You use backward slash and then you type in. So backward slash in, and then you press your R, then you type your except, and then you press x equal to 2 -1, and then you close your curly bracket. So if you want to go and answer my questions, the questions there, you try your hands on it and then know that okay, you remember all the things that I spoke about in the video, then you can do that. So using the backward slash, I repeat, backwards, it's not forward slash. If you use the forward slash, it will not work. So you use the backward slash, this one. So the slash that goes backwards. Then you type in, in. Or if you want to write the second one, you type, you tap. So you type x is such that x. So x is such that x then backward slash in, then comma. So backward in, then r, then comma, you type x. Now not equal to, so not equal to, you type backward slash, then not equal to, so neq. It will give you the function that we are looking at, that is not equal to. Then you put the 2 and then -1. All right, so that was just by the way when you are doing my Google form. Now we go to question 17. Say identify the equations of the vertical asymptote. Now here, for vertical asymptote, you will have to make sure that the graph or the function given to you is in its lowest term. So we try to see if we can factorize something out. So here we can check it out. So if we have 2x squared minus 4x all over all over all over x squared minus x minus 2, what we can do is that we can factorize out, right? So let's see, we have 2x out, and then we have x minus 4 all over all over so all over. Now we have already factorized that we had x, so sorry, here will be 2, so 2x, x minus 2, and then x minus 2, and then x plus 1. Now x minus 2 can cancel x minus 2, then we'll have 2x over x plus 1. Now we have been able to simplify the rational function. So to find the vertical asymptote, we just equate the denominator to 0. So we have x plus 1 is equal to 0, and then when I solve, I have x to be equal to -1. So that is the equation for the vertical asymptote. Now for the horizontal asymptote, we are saying that we should check the degrees if they are the same. If they are the same, then what do? We take the ratio. So when we check they are the same, so we take the ratio. So we write y is equal to the ratio between them, and then the ratio is 2/1, and which will still give us what? 2. Please, one thing I will caution you about is that when you are writing the vertical and the horizontal asymptote, be sure of what you are writing. So for instance, for the vertical asymptote, it is only one vertical asymptote, and then we are going to write as x is equal to -1. So it is always some x equal to something, and then when you are writing the horizontal asymptote, it is y is equal to what? Something. All right. Now to find the x-intercept, we use the simplified function. So let's use that one. So for the x-intercept, y is equal to 0. So that will be x over x plus 1 is equal to 0. I'll do my cross multiplication. I have 2x to be equal to 0. And now what will I have? I'll have x to be equal to 0. So if y is 0, x is also what? 0. So we have 0, 0. So that is the x-intercept, 0, 0. Then for the y-intercept, the same thing applies, where we can say that for the y-intercept, x is 0. So if I put 0 here, 0 here, 0 here, what happens? So I have 2 into bracket 0 over x, that's 0 plus 1. That will still give me 0. So the y-intercept is also what? 0, 0. So if you write only 1, 0, 0, you are supposed to be marked correct. Or you write x-intercept 0 and then y-intercept 0, 0, and then that will be it. But here most people will write and include the one in the domain, which is x is equal to 2. They will write okay 2, 0, and that one will be also wrong. Now when you have all this information, you can use it to sketch the graph. But before you sketch the graph, you know that when you were finding the vertical asymptote, you did some cancellation. That cancellation is termed as a hole. So let's look at that one. So we will find a hole. So when you want to sketch a graph, first check and see if there is a hole in the graph. If there's a hole, you treat the hole first before you move on. You treat the hole first before you move on. So you check the holes. So let's check for holes. So to check for holes, we are saying that when the function you had, they factorize x minus 2 over x minus 2 x plus 1. Now we cancelled this one out, right? So that will be our first point of the hole. That will be 2, because when we solve x minus 2, we get 2. That will be the first point. Now the second point is that substitute this particular 2 into the remaining function. So if I substitute that into it, I have 2 into bracket 2 over 2 plus 1. That will give me 4 out of 3. And so this will be 4 out of 3. So the hole is at 4 out of 3. So I'll come to my graph. And then I'll look for 2 and then 4 out of 3. So 2, where is 2? 2 is here. Then 4 out of 3 will be somewhere 1.3333. So it will be somewhere here. So I'll sketch a nice hole. That is how the hole looks like. Then I'll come and plot my asymptote. The first asymptote, it was y is equal to x is equal to -1. That is the vertical asymptote. So x is equal to -1 is here. So I'll sketch that one. So let me use a different pen color. I have this one. So I'll use short dashes because the questions instruct to use short dashes. So I'll use short dashes. Right. So that is what we have. Then for the horizontal asymptote, it is y is equal to 2. So at 2, I will sketch that. Alright, so I'll sketch that. And then when I sketch that, this is what I have. So I've sketched my horizontal and then my vertical asymptote. Now the next thing is that you sketch your intercept, or you indicate the intercept. And so where is my intercept? My intercept is as 0 0, y is at 0 0, x is at 0 0. So here I indicate that. Very important. Now we check the behavior of the curve along the vertical asymptote and then along the vertical asymptote. So, and then one thing is that when we factorize, we can determine how the graph will look like, or how the graph will lie in all the regions. So if you check and then the multiplicities is odd, when we say multiplicities, the powers of the factorization, the factorized values. So when we factorize, you have x minus 2, x plus 1. The multiplicities are, what is the power of this one? It is 1. And then the power of x plus 1, 2 is what? 1. So they are all odd, right? And so what it means is that the graph will lie in the opposite direction, in the opposite direction of the asymptote. And so if that be the case, this is what we are going to do. So looking at this one, the multiplicities are odd, so they will lie opposite. And if they are even, they will lie in the same that opposite. It will not be opposite, in the same plane. So this one will lie on the left and this one will lie on the right, or this one will lie on the right and this one will lie on the left. So that will be it. So here I want to sketch this particular graph. So I'll check the behavior of the graph very close to the asymptote. So you pick a value very close to the asymptote. Here the asymptote is -1, right? So you can pick a value like 0.99, -0.99. So I have a small table here. So I have negative x and then y. If I pick -0.99, I pick -0.99, and then I'll substitute that into the function. And then if I substitute that into the function, what do I have? negative 0.99 into the function, then I'll have I will see how the graph will look like. So if I substitute that, I'm going to get a very large negative value, and that means that this graph lies just close to the negative. Then I'll test the value also between the interval of 0 and 1 to see whether the graph will come down here or it will go up. So when if I put in 0.5 or 1 into the equation, if I put 1 into this equation, I have 1 here, 1 here. That will be 2 minus 4. That will give me negative 2. 1 here, 1 here. That will give me 0. Negative 2 over negative 2. That will give me 1. So it will be somewhere 1, 1. So that will be here. And so that will come. So that will continue from there to. So let me draw it well. So I have something like this. This passing through the point and then touching the hole. Then I take any value here, very close to the point, and then when I test, you see that they will also move. They will never cross the asymptote. So we'll have that. And then since I know that these multiplicities are odd, the other function will lie in the opposite. It will lie here. So the opposite of this one is this. So it will lie here. So I'll come and test value very close to the asymptote, and that will be, I can choose negative 1.1, and that will give me somewhere 22. So that will be from the positives, and then as I go far away, it reduces. And so this one also lies here. So this one also lies here. Sorry, it should come very close to the horizontal asymptote, and then we'll have something like this, right? So it goes that way. So this is the graph of the function f of x equal to 2x squared minus 4 all over x squared minus 2 x minus 2. So this is how the graph should look like. Now for the Microsoft form, here I drew all the graphs, and I'm asking you to select the one that is most appropriate or most suitable. All right, so thank you, and then also try to check out the quiz 1, 2, and then the assignment. Bye bye.